talking about MongoDB. So a few questions. How many of you are using already MongoDB? How many? No one? You? You or you? You, Alex? Yes, I know. How many of you know about Replica Set? No? Okay. I'm going to explain what is a replica set in MongoDB. So let's begin my presentation. Okay. So what is a replica set? A replica set is a group of MongoDB processes that maintain the same data set. And it is the basic way by design that MongoDB developed to implement high availability, automatic failover. And so the difference, if you know already MySQL, for example, MySQL is designed to be as a standalone server, but but MongoDB is just a little bit different because it was designed to work as a node into a group. So it is not only a standalone server, but by design MongoDB is developed to work in a group of other MongoDB processes. So replica set is the fundamentals to have high availability in MongoDB. So basically we have automatic failover, for example, and we have some internals that are similar to MySQL. For example, replica set is based on asynchronous replication as MySQL replication, for example. And the replication in MongoDB is based on the op log that has more or less the same features as the binlog in MySQL. We have a concept of primary node that is more or less the same as the master in MySQL world. We have a concept of secondary that is more or less the same as the slave. And also we have other kind of nodes we are going to present later. So let's move on. Why it doesn't work as expected? So let's do this way. This is the basic architecture for a replica set in MongoDB. So basically, we have our application that, this is not working, our application that sends, writes and reads to a node that is the primary node. Then we have other nodes, secondary nodes, that are, they replicate the data set using replication, using asynchronous replication. Doesn't work as expected. So what about the reads? All the reads by default goes to the primary. So writes goes to the primary, but also reads by default goes to the primary node. And also the clients that connect to the replica set can decide to have a read preference to send the reads also on the secondary nodes. So this is very good if you want to balance your reads on the replica set. So since the replication is an asynchronous replication, you could have some data on the secondary node that not reflect the same state of the primary node because replication is asynchronous. How it works? We have an internal heartbeat that is implemented directly by MongoDB processes. So it's not an external tool like pacemaker or something like that, but it is an internal tool that, an internal feature of MongoDB itself. And so you just need MongoDB to install high availability. You don't need third-party tools. You just need MongoDB. So let's see automatic failover. What happens when we have, for example, the primary node fails? So if a primary node fails for some reason, the two secondary nodes, in this case, a call for an election. So they both call for an election, and they decide which one of the two will be the new primary node. So basically, the new primary node will be the one that has all the data replicated from the master. So the most updated one will be voted as the new primary. So basically, this node crash after an election that took place in, let's say, more or less 10 seconds, 15 seconds. In 15 seconds, you have the cluster that will elect a new primary and another secondary. So this is all this kind of, this feature is transparent for the application. So the application just needs to connect to the IPs of the cluster, and the application doesn't see anything about the election. Completely transparent. So I'm sorry, I go very quickly because I was supposed to have in the first schedule, I was supposed to have 40 minutes presentation, but I've seen that I have just 30 minutes, so I need to go very quickly. And yes, we have some defaults, some parameters we have to configure into our replica set. So basically, the most important parameters is election time at milliseconds. So by default, it's 10 seconds. So when we have a crash of the primary node, the election can take place in more or less 10 seconds, and we have a new election, a new primary node after more or less 10 seconds. Oh, we have another possibility. Since all the nodes in the replica set need to replicate all the data set, it means that if we have, for example, 1 terabyte of data, we need to have 1 terabyte here, 1 terabyte here, 1 terabyte here. So it would be quite expensive. So we can also do this kind of things where we could have just 2 nodes with the complete data set, and we can create another kind of node that is an arbiter that doesn't have data. The arbiter is just the third one, because to have a cluster that could work properly, we need a node number of nodes, so at least 3. We need at least 3 numbers because in case of network split, we need to have a majority of the nodes in one side of the network, in one side of the partition of the network. So we need 3 nodes at least. So 5, 7, 9, but we don't have to need, we just need to have a node number of nodes because of network split. So in this case, the arbiter has not data, so this machine could be not expensive machine because it doesn't need to have replication to replicate data, but this kind of node can participate during the election to elect a new primary. Yeah, you have other features. So for example, we can define a priority in the nodes. So we can define a parameter, and we can give a weight to each single node in the replica set. For example, this is an example where we have 3 data centers with 5 nodes. And we can define that this node has priority 2, this other node has priority 2, the other one has 1, and the 5th node in data center 3 has priority 0. So what does it mean? All the nodes that have priority 0 will not be elected as primary, could not be elected as primary, new primary. But in this case, in case of a failure of a node, we are sure that the new elected primary will be the one that have the highest priority. So in case of a failure of this one, the new primary to be elected, we are sure that it will be this one. So this is an example of having, for example, data center 1, that is our main site for the data. This is the crash recovery site, and this one, we can use this kind of nodes with priority 0 for backups, for example, or to run some kind of statistics analytics queries. So priority is very important to define which node could be elected as a new primary into the replica set and which nodes don't need to be elected as primary. We can also define a node as hidden. In this case, these kind of nodes are invisible to the application, and so they must be priority 0, so they cannot be elected as the new primary, but they can vote during an election. So they are useful, for example, to run backups, to do statistics or other special tasks for our application. And also we can define delayed secondary nodes that reflects an earlier state of the data set. So we can define, for example, a node that is delayed by 1 hour, 2 hours, 10 hours, 1 day. And so it reflects an earlier state of the data set. So these kind of nodes are very useful to recover in case of application errors. So someone that deleted some kind of data that he was not supposed to delete. So we can recover this data using a delayed secondary node. Also, delayed nodes must be priority 0, so they cannot be elected as the new primary, but the delayed nodes can vote during an election for a new primary. So, how many time is left? Okay, let's move on, and we are going to show you how to configure a replica set. It is very simple, and as I mentioned earlier, we don't need any third parties tool, and just we need to use MongoDB process to configure replica set. So this is a very simple example. So we have 3 Linux machines with Ubuntu, and in this case, Percona server for MongoDB 3.4, but the configuration is the same even with a different operating system or a different version of MongoDB. So these are, for example, the 3 IPs of the nodes. This is the host name, PSMDB1, 2, and 3. So first of all, we need to be sure that each node is accessible by the others on port 270717. This is the MongoDB default port. And so we just can do a very simple task, just try to use the Mongo client, and we try to connect to the other nodes on the default port. So if you are able to connect from one node, for example, from the node 1, we are trying to connect to node 2. From node 1, we are trying to connect to node 3, and so on. If you are able to do all this kind of stuff, so we don't have any kind of error, it means that we don't have connectivity issues. So that's good. If you have some issues here, probably you have some firewalls, so you need to disable any kind of firewalls we have, and you need to be sure that any node can see any other nodes of the cluster. Another important thing is to configure host names. So this is not really mandatory for the replica set to work, because you can use also just the IPs. But since in the last part of my presentation I'm going to talk about the encryption, this is mandatory if we want to configure encryption inside the replica set. We want to encrypt the traffic between the nodes. So configuring the host names is mandatory if we want to encrypt connection between the nodes. So what we need to do is to define into the etc hosts file our host names. On each node, we need to define the host name of all the nodes of the cluster. Very simple. So that's all. We just need to be sure that we don't have connectivity issues between the nodes, and what we need to do to configure a replica set is just to choose the name of the replica set. So let's say that our replica set name is rs.test. So we just need to put into the configuration file of MongoDB that is by default etc mongod.conf, and we just need to put inside the configuration file this kind of string. So replication, section replication, rep set name, so name of the replica set is rs test. And then we just need to restart the server. We put this kind of configuration on each node, on each of the 3 nodes, and that's all. That's all. This is the basic configuration of a replica set. What we need to do now is to initiate the replication. So we just connect to one of the nodes. We don't need to connect to a to a specific node. We just connect to one of the 3, and we issue this kind of command, rs.initiate. So this is a very simple JSON document, and we put the name of the replica set, the same as the configuration files, and then we'll put the list of the nodes, a list of the nodes in this array. So ID 0 node is PSMDB1. This is the default port. ID 1 is PSMDB2, and ID 2 is PSMDB3. So that's all. When I press my enter button, the replication initiates automatically. So that's all. To configure a replica set, we just need to decide the name, and just we need to issue this kind of command on each one of the nodes, and the replication will start. So this is a kind of magic. This is really a kind of magic. I'm going to show just a couple of useful commands we have in MongoDB. The first one is rs.conf, and if we issue this kind of command, we have a list of the configuration of the replica set. So we have, for example, the list of the nodes. So we have node ID 0, that is this one. So in this case, it says that it is not an arbiter. And other kind of, yes, priority 1. So by default, we didn't configure any priority. So by default, priority is 1 for every node, and so on. So other stuff, but in this moment, it's not relevant to talk about all this kind of information. So rs.conf is the command to investigate the configuration of the replica set. Another very useful command is rs.status. It says how the replication is working. So you can see here the list of the nodes, and for each node you can see, for example, which is the primary and which are the secondaries. So in our architecture, we can have just one primary, and all the other nodes will be secondaries. And also in this command, we have a lot of timestamps to take a look at how replication is working, if we have delays on some of the secondaries, and other kinds of useful information. How to test the replication is working as expected? Very simple. We could try to connect to the primary node. As you can see here, when you configure replication and you connect to the MongoDB, once you connect to one of the nodes, you can see here not only the name of the replica set, but also the state of the node we are connected to. So in this case, I'm connected to the primary node. So I enter the test database, and I just try to create a new document. So for example, DB Barcelona, I'm going to insert a new JSON document with just 2 fields, name and surname. So that's OK. One new document was inserted. Then if I do the find to find the documents in my collection, I see that I have my created documents. So this on the primary. So what we can do now is to connect to a secondary. So to test that the replication is working properly, we create a new document in the primary, and just we take a look at the secondaries to see if we have the same document. So in this case, I connect to one of the other nodes, and you can see the prompt that is secondary now. I enter the same database test, I do show collections. So this is show collection is the same as show databases in MySQL. So collection is the same. Sorry, it is more or less the same of show tables in MySQL. So collections has the same meaning as tables in MySQL. So show collection in one of the secondaries, and oops, we have an error. So you can see this. The error message is not a master. Because, why we have an error on the secondary? Because by default, all the secondaries are not permitted to respond to any kind of queries. So only primary node could respond to writes and reads queries, not the secondary. So it is by default. So what we need to do, if you want to read something from the secondary, we just need to issue this kind of command, slave OK. So after doing rs slave OK, I'm going to tell to the secondary, hey, I am a proper user. I know what I'm doing, so I want to read data from the secondary. So after doing rs.slaveOK, I'm able to run again my read query. So I'm going to find out the same document I created on the primary node. This is very important because also if you are using your application and you are connecting to your database using some kind of connector from on your programming language, from Python, from PHP, C#, anything else, Java, you need in any case to specify that you want a read preference to read from the secondary nodes. Otherwise, if you don't specify this, you can't read anything from the secondary nodes. This is by default. So that's all. Configuration of a replica set is very simple. So you just need to decide the name of the replication and just list the nodes. Once you do this, you have a replication completely configured and running very well. That's not very, in the real world, is not so so simple, but the basic configuration is really, really very simple. Then you could have a lot of complexity and a lot of stuff to do. But if you want to test replication on your laptop with just 3 very simple virtual machines, you just need to do this kind of configuration, and that's all. This is really a kind of magic. So this is the most complex part of my presentation, and so I'm really sorry that I'm doing so quickly. Also, I'm also really sorry about my face. I know that you are looking to my face. It's not very beautiful, but so I hope my presentation is best is best than my face. So this is just a little more complicated part. So what we need to do is now to, other than configuring the replica set, we want to encrypt the connection between the nodes. This is very important nowadays because we have, for example, in Europe, we have GDPR. So, for example, to be the GDPR compliant, we have to assure that internal replication is encrypted because someone could connect to the internal network between the nodes and read data, for example. So this is, to be compliant to the GDPR, we need, in most of the cases, to encrypt internal connection. So how we can do this? We have just 8 minutes left, so I'm really, really quickly. So the only way to configure encryption between the nodes is to use X509 certificates authentication, because actually this is the only supported possibility for MongoDB. And so also, in order to use X509 certification, we also need to enable the role-based access control, because by default, MongoDB has not enabled this kind of role-based access control. So you can connect to a MongoDB database without any credential. So this is by default. So we need to enable role-based in order to create a user to use the database. And then I'm going to show how to create the certificates. So first of all, we need to create a new user. So we need to connect to the admin database, and we need to do this kind of command, db create user. We define the name of the user, a password, and the roles, in this case, root. This is more or less the same as a super in MySQL, for example. So successfully, we have created a new user. Then we need to enable the role-based access control. So we need to change something on the configuration file. On the section security, we put authorization enabled, and we restart the server. After doing this, we are forced to connect to the Mongo using a user and password. Otherwise, without authorization enabled, we could connect to MongoDB as an anonymous user. So doing this, we can connect using the admin user we have created. So now, just the more complicated part, we need to create the certificates. So we are going to use OpenSSL to create certificates. If you ever created on your life certificates using OpenSSL, you know that you have to respond a lot of questions. So you have to define a name of the certification authority, your common name. So a lot of details that all this information must reflect your company details, for example. But I was just to point out this kind of information, the common name, CN. This is very important because this must be the same as the host name you have defined on the node. So CN, common name, must be equal to the host name. This is very important. All the other fields, you can put anything you want, just casual strings, random strings, but you just need to remember that you need to put the CN the same as the host name you have defined for the node. Other than that, we need to self-sign certificates because having a public certification authority could be quite costly. And so since we don't have money to spend, we just need to create self-signed certificates. Also because we are talking about a private infrastructure, so why do I have to use a public certification authority? So to do this, first I generate a new private key using OpenSSL. I don't want to command this command, so it is basically how OpenSSL generates certificates. So I'm going to generate a fake certification, a new private key, a new key for our fake certification authority. And the new key is mongoca.key. And also, when you are requested to enter the passphrase, just choose a really strong passphrase. Then, after creating the certificate, I need to create all the keys, all the certificates for each node. So in each node, I need to issue this kind of command, enter all the details, and please remember that when you are asking to enter the common name, this must be the same as the host name of the node. So I create the certificate in the node 1, and I need to put psmd1, the host name of node 1, and so on for the others. So when I'm asking to sign the certificates on node 2, I need to put psmdb2, and so on. Okay, I create certificates on each node, and I use my fake certification authority to sign the certificates. And after I have done this for each of the nodes, so I create for each node a new PEM file. I just need to place these files somewhere. So I need to put the certification of the fake certification authority and the certificate for each node into some directory. So you can put this everywhere, but I choose, for example, ATC MongoDB SSL, and I put in this directory both the files in each node. So the fake certification authority file and our self-signed certification for the node. So this for each node. Okay, that's all. Now I have generated all the certificates. Now I need to configure MongoDB. So as usual, I go in my configuration file and I put some little stuff more complicated, but I just need to configure the SSL stage of the configuration file. So I need to specify that I want to use SSL, and I need to specify the files I have created. So I need to specify the certificates for the node, and also the certificate for our certification authority. And also I need to add something on. So time is over. I have just few seconds. So I need just to put another configuration inside security section. I need to put cluster auth mode as X509. Restart MongoDB, and that's all. Now, to connect to the server, you just need to run your client. You need to specify the user, and also you need to specify your certification authority and also the certificates of the node, and obviously your user and your password. And after doing this, you are sure that internal replication between the nodes is encrypted, but also external connection to the database are encrypted using the same certificate. So that's all. Sorry to be so quick, but just because I was expected to have 10 minutes more. But if you want to review all these stuffs, you could see all in these 3 blog posts on the Percona blog. So you have a blog for the part 1, just the quick presentation about what a replica set is. The second part, you can see how to configure the replica set. And the third part is how to configure encryption between the nodes. So more or less the same you have seen here, so nothing different. So that's all. Thank you. If you have a question about MongoDB, I'm here to respond, but not here because time is over. Thank you very much.